This is a 4K recreation of the breathtaking view actually witnessed by Apollo 13 in 1970. Using precise observational data collected by later space probes, we have faithfully visualized the perspective from 55 years ago. The far side of the moon, which can never be seen from Earth, remains shrouded in mystery even today. What exactly did Apollo 13 see, and what truly happened during this mission? Apollo 13 ultimately returned to Earth after circling the far side of the moon. However, it was originally intended to be a lunar landing mission. The dramatic chain of events that forced a complete change of plans will be explained later in this video. First, let us take a look at the lunar surface as seen by Apollo 13. Slowly, Apollo 13 drifts away from Earth. Once in deep space, the familiar concept of day and night disappears. In real photographs, space appears as an overwhelming, endless darkness, as if it could swallow you whole. Human senses of depth and direction become almost meaningless. Soon, Earth slips behind the moon's shadow. After Earth vanishes completely, lunar night begins. It is a dark, silent world, isolated from all sources of light. The moon always presents the same face to Earth and never reveals its far side. This is because the moon is tidally locked to Earth. The Earth and the moon orbit around a shared center of gravity. Since the moon's rotation period matches its orbital period around Earth, the same side always faces us. Jupiter's moon, Io, and Pluto's moon, Charon, are also tidally locked in the same way. In the moon's case, however, slight variations in its orbit and tilt cause small changes in the surface visible from Earth. When Apollo 13 entered the far side of the moon itself blocked radio waves, cutting off communication with Earth for about 25 minutes. Gradually, sunlight rises over the lunar horizon, illuminating the surface. From the darkness emerges a vast crater-covered landscape. Apollo 13 observed the moon while flying at an altitude of 254 kilometers above its surface. The countless craters blanketing the terrain look much the same on both the near and far sides of the moon. At first glance, the far side appears to be a barren, heavily scarred wasteland, yet this footage reveals several prominent craters. First, Killer Crater. At its center rises a mountain-like peak, and within the crater lies an even smaller crater. Next, Tsiolkovsky Crater. With a diameter of approximately 123 kilometers, it shows dramatic rock ejecta blasted outward by a massive impact. Then, Marconi Crater. This image was taken by Apollo 17, showing Marconi at the center, with Tsiolkovsky to its upper right. And finally, Gagarin Crater, named after Yuri Gagarin, the first human to travel into space. The moon's gravity is only about 1/6 that of Earth, and because of its low mass and weak magnetic field, it cannot retain a substantial atmosphere. Compared to Earth, its atmosphere is so thin that it is almost negligible, leaving the surface exposed to relentless meteorite bombardment for billions of years. One of the most striking features on the lunar surface is Tsiolkovsky Crater. With a diameter of 185 kilometers, its sheer scale is overwhelming. While the surrounding terrain is rugged and uneven, the interior is surprisingly smooth. This flat region is known as the lunar mare, referring to the dark areas visible on the moon's surface. These plains are composed of basalt formed by lava flows more than 2 billion years ago. At the center of this mare stands a solitary mountain rising more than 3,400 meters high. It was formed when bedrock rebounded upward after the massive impact that created Tsiolkovsky Crater. After a long absence, Earth finally reappears above the lunar horizon. With this, communication between Apollo 13 and Earth is restored. One of the largest maria on the far side of the moon is the Mare Makovians. Within this vast impact basin, numerous small, shallow craters can be seen. According to NASA's database, its diameter is about 275 kilometers. At first glance, it may not appear very deep. However, the total elevation difference across the basin reaches 11.4 kilometers, nearly 3,000 meters higher than Mount Everest. After several intense volcanic episodes beginning around 3.5 billion years ago, the basin developed its distinctive nested crater structure. It may hold vital clues to unraveling the moon's mysterious origins. This scene occurs just minutes after communication with Earth is restored. Of the two Marias stacked vertically, the upper region is Mare Marginis, and the lower one is Mare Smithy. Both lie on the eastern edge of the moon's near side and can barely be seen from Earth. Mare Marginis has a unique paw-like shape unlike any other lunar sea. It likely formed through a combination of volcanic activity and meteorite impacts, reflecting the diverse origins of Lunar Maria. Apollo 13 slowly turns its back on the moon and begins drifting away. The communication blackout on the far side lasted no more than 25 minutes, but for the astronauts, it must have felt like an eternity. At that moment, they were facing a life or death crisis. What exactly had happened to the crew? On July 20th, 1969, Neil Armstrong of Apollo 11 became the first human to set foot on the moon. It was a historic moment, humanity's first step onto another world. The brave astronauts were broadcast live to billions of people across the globe who watched in awe as history unfolded. Yet human nature is strangely fickle. The immense success of Apollo 11, followed by Apollo 12, made lunar landings seem almost routine. At the same time, the escalating Vietnam War gradually shifted public attention away from the Apollo program. Amid this atmosphere, Apollo 13 was preparing for its launch as the third lunar landing mission. Many were uneasy about the ominous number 13. Just before launch, pilot Ken Mattingly was replaced by Jack Swigert due to concerns over illness. Among the three crew members, only one had previous spaceflight experience. An unspoken sense of unease lingered among mission personnel. The Saturn V rocket lifted Apollo 13 from Kennedy Space Center. Although minor anomalies occurred, the mission progressed smoothly. Mission Control even remarked that things were going so well it was becoming boring. Then, the calm was shattered by a terrifying explosion echoing through the spacecraft.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem. We've had a main B plus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
An oxygen tank supplying life support detonated violently. One tank was completely depleted, and oxygen levels in the second tank dropped rapidly. Two of the spacecraft's three main fuel cells also failed, crippling the electrical system. Power, lighting, and water supplies were nearly lost. At that moment, the spacecraft was about 320,000 kilometers from Earth. No rescue mission could possibly reach them. In an instant, humanity's most advanced spacecraft became a drifting lifeboat. Abandoning the lunar landing was unavoidable. The mission was redirected to loop around the far side of the moon and return to Earth as quickly as possible. Apollo 13 consisted of three main sections: the lunar module for landing on the moon, the command module where the crew lived, and the service module, which provided oxygen and electrical power. The explosion occurred in the service module. This image shows the module after it was jettisoned 138 hours into the mission. Panels were blown completely away, scattering debris into space. With power in the command module rapidly dwindling, the crew moved into the lunar module, whose oxygen tanks remained intact. They would spend the next 3.5 days confined within this tiny space. The lunar module was never designed for long-term habitation. Its intended operational time was just 45 hours, yet it had to be stretched to nearly 90 hours. With no way to restore sufficient power, the crew shut down most onboard systems to conserve energy, enduring freezing temperatures so cold their breath turned white. Their daily water ration dropped from about 1 liter to just 1/5 of that amount. They survived on small amounts of fruit juice and limited food such as hot dogs. Even under these extreme conditions, the crew continued to observe the moon whenever possible. The greatest challenge was figuring out how to return safely to Earth. With their trajectory radically altered, new calculations were urgently required. Yet the navigation system that controlled the spacecraft's orientation had failed. The astronauts manually aligned the spacecraft by visually referencing the horizon between Earth and space. The lunar module was not designed for atmospheric re-entry, so the crew had to return to the command module, which had been powered down. 4 hours before re-entry, the lunar module was jettisoned. During atmospheric re-entry, communication with Earth was completely lost. Mission Control could only wait and hope. On April 17, 1970, the command module finally splashed down in the Pacific Ocean. After a total flight time of 5 days, 22 hours, and 54 minutes, all 3 astronauts returned safely to Earth. Upon recovery, Commander Jim Lovell had lost about 6.3 kilograms, while Fred Hayes and Jack Swigert together had lost about 7.7 kilograms. Had their return been delayed any longer, they might have died from oxygen deprivation and dehydration. At their farthest point, the crew traveled 401,056 kilometers from Earth, the greatest distance any human has ever reached, earning a Guinness World Record. This miraculous survival story from one of the worst accidents in spaceflight history reignited public interest in the Apollo program. Subsequent investigations revealed that the oxygen tank's wiring and insulation had been damaged during ground testing. When voltage requirements changed, the tank was never properly redesigned. Safety devices had already failed during testing, yet the danger was not fully recognized. Even when abnormalities were detected, they were dismissed as routine issues. Furthermore, the exploded tank had previously been involved in an accident in 1969, and after repairs, it was reused without thorough reinspection. NASA's failure to address these hidden problems ultimately led to the disaster. From a scientific standpoint, Apollo 13 may seem less successful than other missions. Yet it exposed critical organizational flaws within NASA and provided invaluable lessons for future space exploration. Remembered as a successful failure, the mission of Apollo 13 remains a story that must never be forgotten.